Greetings, family, and welcome to Introduction to African Math. My name is Nkosi, and I am here with,
Jelani.
and we are about to jump right into this African Math lesson one, Introduction to African Math. So the first thing you need to understand about African Math is that African Math it stems from an ancient learning system in which we practice numeracy, and we taught numeracy through fun games. So traditionally, Africans have taught numeracy through engaging and enjoyable games. The game you see on the screen is called Diketo, which is common in South Africa. There's also Mancala, Ware, Bao. These are categories of Mancala games, and they are amongst the earliest examples of numeracy games that Africans have played for tens of thousands, if not hundreds of thousands of years. So what you're going to need in order to participate in this African math learning culture is you're going to need your game pieces. So you're going to have to get your game pieces if you want to play the game. So what we need you to do is we're going to start you off with these game pieces called math links, or they're also called math cubes. And they're very popular. Make sure that when you get them, you get the ones that connect on all sides. They have to be able to connect on the top and on the bottom and on the sides. That's very important. Some just connect top and bottom. Make sure you get the kind that connect top and bottom and on the sides. Here, I'm a real big fan of this brand called MathLink Cubes. And I really advise that you get the 1,000 piece set. The reason it's important to get the 1,000 piece set is because you're going to need multiple groups of tens, and you're going to need them to actually get all the way up to 100. So the only way you can get that 100 is if you get the 1,000 piece set. So that's what you're going to need if you want to follow along and play this fun African math game with us. You don't need your pieces right now. Please watch the video. You're going to see how we're going to use them later. Now that you know what game pieces you need to understand that we use a measurement system that's a standardized measurement system that can be traced back to ancient civilizations like the Egyptians, the Romans, the Greeks. Even the Sumerians used this ancient unit of measurement called the cubit. And the BITRIC system is the measurement system based on this ancient standard unit of measurement. And if you go here, we're going to show you the smallest unit so you can understand that the BITRIC system is something that's called multi-numeral, meaning that there was this sophisticated understanding of multiple number systems. So Africans are very multilingual, but what people don't understand is that ancient Africans were very multinumeral. So if you see here, you see this symbol right here represents 1/2. And the mouth symbol that you see here is a fraction. It's saying that this is 1/3. And notice that the digit is broken into 3 parts. The mouth symbol is here, got a little damage, but as you can tell, it says 1/4, meaning it's broken into 4 parts, and so on. 1/5, 1/6, 1/7, 1/8, 1/9. This symbol right here, which represents an Nguni house or an arch entering a doorway, that is the symbol for 10. So this is 1/10, and this is the root of our decimal system, or our BITRIC 10 system. What we use today, we commonly call it the metric system. Well, this is this birthplace where for thousands of years ago. So this is a base 10 system that we call BITRIC 10 because we have to use so many different number systems. So this would be BITRIC 11. And this would be BITRIC 12, which we use here in America for dozens. And we also use it for our inches. And this is BITRIC 13, BITRIC 15, BITRIC 14, BITRIC 15. And lastly, we have BITRIC 16, which is very commonly used here in America as well for our inch, as well as we use it for a pint, 16 ounces. And in the construction industry, we build things 16 inches on center, like when we frame walls. So that is the catalyst of what the BITRIC system is. The BITRIC is a standardized unit of measurement that can be traced back to antiquity, that's based on what we recognize as the ancient cubit. And we'll get more into that as we have fun and get along. This lesson will be BITRIC 10, and we look forward to having fun playing these games with you. All right, family, now that we've learned what we need, we're going to need those snap blocks if you want to play along. And now that we understand that BITRIC is an ancient measurement system that can be traced back to ancient civilizations, all the way back to ancient Kemet, ancient Egypt, ancient Sumeria. They all use the ancient cubit system, which is what BITRIC is today. Now, what we're doing today is a BITRIC 10 system, and we're going to go back in time to what we call ancient African numerals. Many people refer to them as ancient Egyptian numerals. And this is one of the first recorded place value charts of the ancient world, and it was a base 10 system. Again, ancient Egyptians were multi-numeral, and they used the BITRIC system, which used base 10, base 16, base 12, and we still preserve that heritage here in America today. But what we're going to learn now is the base 10 system. And this is the place value chart, where this line here represents a finger or a digit. This line, or this shape here, represents an arch for a doorway or an ancient Nguni house. And this represents a coiled chain or a coiled rope. So when you start getting into surveying, you start getting into an area. This is the lotus flower. Of course, this is a finger. A tadpole and also frog represents 100,000. And this man here represents 1,000,000. But what we're going to focus on primarily is just units, which we call bits. The smallest unit of measurement, we typically call it bits, because we use small counters called bits, or also the BITRIC system. And we're going to focus on the house of 10. Later, we're going to get into the chain rope for 100. But for now, our primary concentration are just going to be here as far as the ancient African numeral place value system. So now what you need to do is you need to learn your game pieces. So now that you know you need those snap cues, here's why. So remember earlier, I was telling you that the ancient BITRIC system is a body ratio system. And it's very practical when it comes to teaching learners, because they learn their body parts. So here you see we have, earlier in our place value chart, this digit represents 1, or it's also a tally mark. We're going to come here, look at our unit for 1. This is our tens column to the left, representing groups of 10. And this is our bits column to the right, representing smaller units or bits. Some people call this the ones column. We call it the bits column. Now, when using the system, the reason you want to have the counting blocks is because you have to build up groups. If we don't build groups, we can just count by ones. We have 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, and so forth. But if you just keep counting by units and don't use groups, counting becomes very cumbersome and inefficient. It helps to take units and bits. It helps to take units and bits and to organize them into larger groups. So the first group you have in the BITRIC system is a group of 1. Then there's the group of 4, which is called the palm. 4 units is called the palm. The palm is a very important unit of measurement in other BITRIC numeracy systems, especially BITRIC 8, BITRIC 16, BITRIC 12, which is again commonly used here in the United States of America, because we use BITRIC 8 for the cup, BITRIC 16 for the pint, we use BITRIC 12 for the foot. So we need to use the palm because it's a more efficient use of measurement in our multi-numeral system here in the United States of America. The metric system, however, is different. It uses a different group of measurement. The group of measurements that the metric system uses, which is the same as BITRIC 10, is called the palm. What we'll be using for BITRIC 10 primarily is the palm. I'm sorry, not the palm. BITRIC 10 will be using the hand. So this unit of measurement of 5 is called the hand. For BITRIC, again, 2, 4, 8, 16, 32, 64, the palm is a must use. But for BITRIC 10, which is what we're using, what we're learning this game, the primary group that you're going to need is you're going to need, and at least in your bits column, you're going to need 1, and we're representing 1 finger or digit, and we're going to need the hand, which is 5 units or 5 digits. So please orient your game pieces this way. Build your 5 by having a 4 plus 1, because our number system uses this notation in our number system, but also we use the 3 by 2, the 3 by 2 hand, which we'll get into later. Okay, so that's our bits game pieces. Now let's dive into our next group. Our next group is, and you're going to need to build these game pieces, is our 10-bit game piece, which we often call a house of 10, especially in the African abacus. When we use the African abacus, we have the beads, and then the holes that we use on the African abacus we call houses. So we've called them houses for thousands of years. So this toy that you're going to build, we don't use the term manipulatives in African math. That's a relatively new term. Again, we have a play-based numeracy system, so we call what the West calls manipulatives, we call them math toys. Make sure to build this math toy in this shape because it represents a house of 10. And that way you can see the correspondence with the ancient African numeral for the house of 10, as well as the correspondence with the shape. We want those. So it's basically it's a 6 plus 4 system. So this is what your 10 will look like. Remember to get those 1,000 piece game sets because you're going to need multiple 10s. We're going to need at least 10 houses of 10s to get to 100. That's why you need the multiple numbers game set. Now, I do have some news for if you are familiar with a game here in America that's becoming very popular. It's called the Quick 10 system. So for African math, you can use a Quick 10s system. The only thing that Quick 10s, we're not going to do that right now. We're not going to use Quick 10s right now because Quick 10s is confusing when it comes to our place value system, because the 10s notation is the same as our 1s notation. And we'll clear that up in later lessons, but we just want you to know that if you are playing in America with the Quick 10 system and you look it up online, it's okay to build your house of 10 like a skyscraper, to build it as a straight rod like this. So those are our game pieces for units in 10s. And then there's even more game pieces that we have to get into. And those game pieces are related to our next lesson, which is going to be 0 pairs. So let's dive right in. Now that we've gone over what we need, we need those snap blocks. We know about the ancient BITRIC system and its relationship to the cubit. Now we're still learning about the game pieces. You got to get a glimpse at the game pieces that you're going to need to build. So once you get your snap blocks, your MathLink cubes in, you can start building those. There's an additional game piece that I've yet to show you because we need to take a walk back in time to get the concept of understanding of zero pairs. Now, what are zero pairs? Zero pairs are basically a concept that my ancient African ancestors came up with to make sure that there was balance. So they had to define zero. And the way zero was defined was by having complements or having opposites that created a zero. So what you see here is the concept of placing something, which is used with what's called the BITRIC seed. They're also called C beans. And today we use this as to represent our positive integers. So we're using our math toys to represent a quantity. Now, what you see right here, this would be positive 5. If I were to take away 1, that would be positive 4, positive 3, positive 2, positive 1, and 0. But what our ancestors realized, and shout out to Nigerians because this is embedded in their counting system, where they count using negative values. And our ancestors created tangible representations of negatives using cowrie shells. So we use cowrie shells today. That's that's our relationship to the subtraction symbol. Now, one could also argue that it's a tally mark, but we use it as our subtraction symbol. So this is indicative of a takeaway, and this is from a cowrie shell. So what happens is when you put a positive C bean or BITRIC seed with a negative cowrie shell, this is the equivalent of 0, which is the same as what you'll learn later when we teach quantum physics and quantum mathematics, where it's very important to have an understanding of the concept of a zero pair. So the way that works is if this is place and this is a race, then together they make 0. Why this is important is, let's say, if you have 3 takeaways, okay, and then we place 2 positive beads, that creates literally 0 pairs, which are the equivalent of a 0. And with that understanding of that be a 0, those go away and you still have a negative integer or a negative answer. So this conceptual understanding of how can a negative be greater than a positive is easily understood when using the ancient African 0 pair math toys. Now, cowrie shells and sea beans and BITRIC seeds are all over Africa. They're very easy to find. You can find them by the millions. Unfortunately, they're not as easy to find here in America and throughout the West. Feel free to shop for them online. You can find them, but they're not as common as other math toys that we're more familiar with. So what we've done is we have a modern representation of the 0 pair concept by using counting toys that are related to the snap blocks that I showed you earlier. And that is what we're going to use to play these math games. If you would like for us to teach you the math games in the 0 pairs using the ancient 0 pair counting toys, we would be happy to. Just leave a comment below and subscribe, and we'll be happy to see if we can schedule some type of online course to give you more introductions into basic numeracy using the ancient 0 pairs, the ancient African 0 pairs. But what we're going to do as we dive into this lesson is you're going to need to get your modern African math 0 pairs, which is we're going to go into now. All right, that was fun. That was a whole lot of fun. So we went through what you're going to need. Now you got an idea of what BITRIC is. You know your game pieces. and the rules, but we're going to get a little deeper into the rules. And now that you know about our ancient zero pairs, we can jump more into the modern zero pairs. You know, remember earlier where we showed you the game pieces? I'm going to bring them back out. Remember your math link cubes and your snap blocks. So you have to build a palm, which is 4 units, or a hand. This is our units column. And then you have here, this is our tens column. Now you can use the house of 10 that reminds us of the ancient African numeral, or you can use the skyscraper 10 or Tekken 10, which is a vertical line. Again, my advice for now is use the ancient African numeral 10 versus the skyscraper. Now, if you're in America, again, it's very important if you are in America to go check out any videos that you can on what's called Quick Tens on YouTube. Quick Tens uses a similar notation system to the um, ancient African notation system, but they use bits, they use dots as their units column instead of tally marks. And I'll get back into that if anybody wants us to teach quick tens in the US using the notation system. Just leave a message in the chat. Just leave us a comment and we'll get back to you if we have time. And then just go ahead and subscribe and leave a comment and then we'll get back to you. Okay, so we're going to start by using the ancient African house of 10 as our toy in the notation system. This is a BITRIC 10 system. So you see right here, the palm is very important when it comes to BITRIC 4, 8, 12, and 16 games. But since we're doing BITRIC 10, which is the same as the metric system, we'll go ahead and just go ahead and put the palm to the side for now because it's not really needed for this game. So when it comes to modern zero pairs, showed you the ancient zero pairs. Now we have zero pairs for our modern BITRIC games. The zero pairs are always red in our system. So you see, basically, when you put these together, they form. So you see that this is one finger up, and this is basically saying that one finger, put your finger down. And the zero pairs, the combination of these symbols is awesome, is because the combination of them makes our symbol for zero. So if you see here, a zero for the BITRIC number system and the African math system is reminiscent of the cowrie shell, where it's basically a circle and then there's a line in the center. That's what our zero looks like. It's either a circle with a line in the center or a circle with a dot in the center. And that's what our zero pairs look like. It's very important. They look like a combination of the positive and the negative. So we make a point to put them together. So you see here where the circle is red, because takeaway is always red. And the reason takeaway is always red is because in accounting and in modern accounting, a negative or a takeaway is always red. So when someone says that you're taking a loss, that they'll use a term like you're in the red, it's because you're below profitability or you're below a certain mark point and you're negative. So we use red to represent negative because it carries forward throughout life. The reason we use yellow as our positives is because later when you get into our algebra system and algebra tiles, our algebra tile system uses yellow units, green tens, and blue hundreds. It's very important because that's the color system that's used with algebra tiles, that we continue to use that as our base for our our system here, where it's yellow as units, green as base 10 for the line, and then blue for 100 as the square. So as we move into hundreds, those would be blue. Now our negative again is red. So this would be red, and that would be a zero pair, meaning place one, erase one is the same as zero. So that would be a zero pair. So now it's important that when we do our zero pairs for our modern zero pairs, that we go to our toys, our counting toys, which are the math linking cubes. And we know that we have a zero pair for our unit. We know if we combine these two, that they make a representation for zero. So that's our number. That's how we actually would even write the number zero. So you see how that makes our zero pair? And that's a combination of our open circle, which is our takeaway, our straight line, our tally mark, represents a digit, finger, or a stick. And that's our positive. Keep in mind also when we do dots, because we use bits and dots like the C-beams or the Botic seeds that we use little dots to also represent our units. We call those bits. So a circle around a bit also represents a zero. So a circle around a tally mark or a digit and a circle around a bit represents a zero pair. Now, the same way we have a zero pair for our units, we also have a zero pair. Same way we have a zero pair for our units, we also have a zero pair for our hands. So you see how we have our positive toy, we have 5 fingers up. Well, the thing that's interesting about digits is that they can represent, or integers, they can represent both particles and they can represent waves. They can represent an object and they can represent an action. And the positive play toys, count them out 1, 2, 3, 4, 5. That's a positive object. But if I were to tell you to also use them, you can use it as put up 5 fingers. This takeaway hand is saying that take away 5 objects or put down 5 fingers. And again, when they are atop one another, the positive and negative, they make a zero pair. So make sure that you also build a takeaway toy for every single toy that you build that's place. You need to build a toy that's erased. So that's a zero pair. The same is true for our house of 10. The green represents place 10, and then the red will represent take away 10. Here's what's very important. The symbol for takeaway when it comes to the tens column is an upside down T. The reason that's important is because when you blend these two shapes, or yes, when you blend these two marks or shapes in ancient African numerals together, you'll get a zero pair. So you see how you have zero pairs for each one of your units, the same as this is what a zero pair 10 looks like. So when you put that negative 10 or take away a house of 10 with the positive 10, you should get a zero pair symbol. And that's when you'll understand, oh, if I take away 10, this is take away house of 10. So now this is a zero. So this is what a zero pair looks like, which is very important when we get into our BITRIC numerals and our ancient African number system to be able to readily recognize the pictorial representation of your zero pair. So for a little review, we went over the counting toys that we're going to need. We went over BITRIC. We're still learning the rules, but we went over the game pieces. Went over ancient zero pairs, modern zero pairs, and now we're going to start to dive into something that's very important when it comes to African math, and that's the importance of language. That is very important. Now, what I learned when I visit the motherland and I met my wonderful brothers and sisters there, I learned that our ancestors embedded certain algorithms into our counting system. And these are some incredible algorithms. I encourage anyone who speaks an African language to make sure that you learn how to count in your indigenous language or your mother tongue, as well as learn how to count in an international language, very commonly used language like English, even though there are advantages to African languages that hide within them. They embed within them very advanced algorithms. So when you learn these counting systems, you'll learn some very sophisticated methods, especially when I learned in South Africa that they have an ancestral way of counting that perfectly matches the African math system. So it's very important. It's very important when learning how to count that you count, if possible, in an African language and in an international language. We use, of course, English here in America. It's one of the most widely used languages on earth, and it is beneficial to know how to count in English, but you need to change the style of counting in English to the framework and format that ancient Africans used. I advise you to get a better understanding of this by going to our YouTube channel at African Math and watching this video. It's called Counting Swahili Style.
Greetings, family, and welcome to African Math. Today we're going to learn about counting. Counting is very important. When learning mathematics, one of the first things we must learn to do is count. Did you know people have different ways of counting all over the world? Kenya is a country in East Africa. Kenyan people speak an ancient language called Swahili. The structure of the Swahili counting system is a little different than the counting system we use in English.
My advice is to go back and watch that video, and I think it'll help you tremendously when it comes to understanding how to count structurally. We're going to do that now as we clear our play space and we start to count Swahili style. Hopefully you watched the African Math Counting Swahili Style video. If you didn't, what's important to understand is that when counting in English, learners have a difficulty when it comes to the numbers beyond 10, like 11, 12, 13, because Africans historically counted according to place value. So let me give you an example. We would count in English 1, 2, 3, 4, which is a palm. And we would clear fractions of 5, and then we would carry in a hand, which is 5. Continue counting 6, 7, 8, 9. Then clear a fraction of 10, and then carry in a group of 10. Here's where English becomes confusing. We would then say 11, 12, 13, 14, and we would clear fractions of 5 and carry in a group of 5, 15, 16, 17, 18, 19. It's important when counting, when we count in English, notice that I was saying we have 10, 10, then we have 19. So currently we have 19. Well, again, English being a young language, never learned to count according to place value. There is place value embedded within the English language, but it's not easily recognizable when especially counting objects. So if you watch the video on counting Swahili style, the way we would translate that into English would be, we would count in 1, 2, 3, 4. We're going to clear fractions of 5 and bring in a group of 5. Then we'll count in 6, 7, 8, 9. Now we have to clear a fraction of 10, carry in a 10. And the appropriate way to continue counting according to African place value, like Swahili style, is to count. Now we have 10, and then you start again at 1 versus saying 11. So instead of 12, you would say 10, 2. Instead of saying 13, you would say 10, 3, 10, 4, 10, clearing away fractions of 5 and carrying a 5. So instead of 15, which is not recognizable according to place value, African style format of counting linguistically would be literally 10, 5, or 10 and 5. And then counting on, we would have 10 and 6, 10 and 7, 10 and 8, 10 and 9. Instead of 17, 18, 19, which is confusing. And then we would go on, we would clear a fraction of 10, and then we would carry in another group of 10. So now we have 2 10s. Now, what's good about English, to its credit, is that once you get past the 11 to 19, 20 and beyond starts to use the African format of counting. Twin means twice or two, like you have two babies that look alike, they're twins. T means 10 in the English language. So if we were to count 20, that means the twins of 10. If we were to count 30, that means T means 10. So that will literally mean 3 10s. 4T means 4 10s. And that's where we have 50. We'll have 5 10s. Like I said earlier, English is a relatively young language compared to ancient African languages. So it's our brothers and sisters in England and America are learning how to count using place value. Now, to their credit, to English credit, it does count according to place value after the teens. So between 11 and 19, we then start counting according to place value. And the way to easily recognize that is that the letter T means 10. So this would be 10. And then after 10 would be T representing 10. So twin T means two twins look alike, twin T, 2 10s. Third T is 3 10s. 4T, 4 10s. 5T, which is pronounced 50, is 5 10s. You have 6T, which is 6 10s. 7T, which is 7 10s. 8T, which is 8 10s. And then you have 9T, which is 9 10s. So the only problem you have when it comes to counting using a place value system, like we counted in antiquity, is between really 11 and 20. But once we get beyond 20, everything gets pretty much counted according to place value. And that's how you count African style. All right, about to move on to the next chapter. Hope you enjoy. Make sure you get your counting toys and you practice counting every day. Now that we've counted forward 0 to 10, we're going to now start to count backwards. I'm going to bring in a 10. And the way we would do this is we could have a number of ways in which we can count backwards. We can take this 10, we have a grouping and ungrouping method called clear carry. We're going to clear the group and then we're going to carry in a fraction. So we can carry in 2 5s, which is the same as a group of 10. Then we can clear a hand and we can bring in 5 digits. So now that we have one hand, which is 5, and then we have 5 digits, that is the exact same as 10. So now we can start counting away the digits. So this would be 10, 9, 8, 7, 6, 5. Now before we can count away this 5, we have to ungroup it. So we're going to clear away a group of 5, and we're going to carry in 5 digits. So this would be 1, 2, 3, 4, 5. Well, now we can count backwards from 5. We have 5, counting away, 4, 3, 2, 1, and now we have 0. Now, what I learned in South Africa, and Nigeria does this too. Nigeria, I have to give a shout out to Nigeria. Their counting system is so sophisticated that they have a base 20 counting system, and they'll count up to 20, and then when they count forward, they'll say 20 take away 1, or 20 take away 2, 20 take away 3. It's a phenomenal system. And I was amazed when I was in South Africa that they count the same way. They have a term, Isi Shiaka, and then have the term Isi Shiaka Lolunye, which literally means 10 take away 1. And then they have Isi Shiaka Lombili, Isi Shiaka Lombili, which means 10 take away 2. So instead of ungrouping, they will literally just use a negative counter instead of having to break that 10 into 2 5s and then 10 units. These ingenious mathematicians of antiquity embedded a counting system that made it easy to just use a negative in a company with a larger group to basically make the group smaller without ungrouping it, which is very advanced. And so shout out to South Africa, our Ngunian brothers and sisters in South Africa, and our Nigerian brothers and sisters. Please go look up the systems on internet, the counting systems for counting in Zulu or in Nguni languages and counting in the Nigerian languages. So for us to do that in English, we would basically say, okay, we have 10, and then Isi Shiaka Lombili, Isi Shiaka Lonluye would be 10 take away 1. So this would be the same as 9, but we would count 10 take away 1. And then Isi Shiaka Lombili would be 10 take away 2. Now, Nigerians keep doing it up by 20, but what I saw in Mzansi when I went to South Africa, and correct me if I'm wrong, is that at this point they would clear the groups and the takeaways, and then they would bring in the equivalent of 8. Well, actually, I'm sorry, the equivalent of 7, because Isi Shiaka Lumbili is 8. It's 10 take away 2. So then they would bring in the 7, and that would be 7, 6, 5, clearing away 5, and bringing in a fraction of 5, which would be 5 units. And then we can count away from this 5 to 4, 3, 2, 1, and 0. Please, I really advise everybody who's listening, I don't care what country you're from, I don't care if you're African or non-African, please go look at the counting structure that is used within ancient African languages. Inarguably the oldest languages on earth, Africans have been counting for hundreds of thousands of years, and the sophistication of their counting systems was embedded into the languages. So there's untapped knowledge and genius in the everyday counting languages of African people all over the world. So I look forward to hearing back from someone. Please, anyone, give me a comment and subscribe. Leave it in the comment area, and we'll try our best to, if we can find time, to get back to you. If you need any African math lessons for your educators or for your school or your homeschool group, just please leave that information in the comments. And if we can find time, we'll try our best to see if we can teach you more African math on a private level, on a personal and more private level. Thanks a lot for attending this lesson. My name is Nkosi, African Math. Love you all. Happy learning.